This is a bit of an unusual transformations problem because it's asking you how is the domain and the range of this function being transformed. Usually it just says how is the equation being transformed or how's the graph being transformed, but this time we have to look at the domain and the range. And in some ways this is no change at all because we're still going to focus our attention on those transformations, figure out what order to put them in, and how to turn those into math steps. Okay, that procedure is what I'm describing right here. So let's go ahead and figure out what are my horizontal transformations. For now, I'm not talking about vertical, just focusing on horizontal. So you remember the horizontal information is always located right here inside the parentheses. And when I look at that, I see there's several things going on. One is that there is a horizontal reflection, that negative sign. Two is that there is a scaling factor. Now, this is tricky because if you remember, everything in the parentheses is always a little backwards from what you expect. So when I see 1/2 inside the parentheses, I know that's actually a scaling factor by 2, not by 1/2. And then there's a shift also, but that's backwards time again. Remember that +4? That actually means a shift left by 4. So that's the order that I'm going to go in. Remember, shifts come last, and horizontal is the tricky one because everything's kind of backwards time in there. So let's go ahead and do this. And I'm going to do something a little strange, which is I'm going to literally grab the domain and I'm going to bring this over here and work on it. So step 1, step 2, and step 3 is how we're going here. First of all, starting off, let's just write the domain. It's -9 to -2. Now, step 1 has me turning that into negative number, or flipping the plus minus sign. So this is going to turn into +9, +2. Okay, I just multiplied by a -1. Step 2 has me scaling everything by a factor of 2. So this will become 18, 4. And step 3 has me shifting everything over to the left, which means 18 becomes 14 and 4 becomes 0. And you could write this as your answer, except for one thing. With interval notation, you have to go from negative numbers on the left to positive numbers on the right. And this thing turned out to be backwards because of that flipperoo that we did with the reflection. So we're just going to rewrite this and say 0 to 14, preserving the brackets and parentheses wherever they should be. And that is my answer for the domain of the transformed function g of x. Let's try it again. Same idea, except this time we're going to work on the y values. So in terms of my reflections in business, what do we have here going on vertically? So now I'm looking, let's be careful about where we're looking. Now I'm looking on the outside of the function, right here and right here, not inside the parentheses, outside. So first I have another reflection. There's a vertical reflection on this one, and there's a vertical scaling factor. So that's a scaling factor, but this one's not backwards. This is a y value. You can trust the y values. They're exactly what they look like. This is just a scaling factor by 1/3. And then a shift, again, y values are trustworthy. The minus is actually down. It is what it looks like. So if I go in the order of reflections, then scalings, then shifts, and I guess the only really important part is that the shifts come last. So let's work on our range of this thing, which according to the original equation started out as 4, 7 with a bracket on the 7. And now we're going to go through each of these steps. First, step 1, I change these to negative signs because it's being reflected. Step 2, I scale everything by a factor of 1/3, which is annoying. You're going to have to do -4/3 and -7/3, right? We have fractions to deal with. Can't avoid that. And then step 3, running out of a little space, so I'll bring it up here. Step 3 means everything is shifted down by -1, which means subtract 1 from these. So that becomes -7/3 and -10/3. That might take you a moment to wrap your heads around, but all I'm doing is I'm saying -1. And now we have to fix the order. It's gotten out of order again because of that reflection, so I'm going to flip it around and say this goes from -10/3 on the negative side to -7/3. Hard to say the positive side, but it's the less negative side. So that's how you handle domain range. Same idea with PEMDAS, and order of transformations. Just have to turn them into mathematical terms and then work on this interval as if it were a number being transformed.